Welcome back. We are moving on. Lesson 4, trigonometry. We are still looking at how to determine theta when we are given trig ratios. I've been looking at how to get the ratios when you're given the angles. How about if you are supposed to get the angles when you're given the ratios? That's what we are talking about right now. And when you look at Roman 3, because we've looked at Roman 1 and 2, we have cos of theta plus 60 degrees is equal to a half. Remember that the whole of this is altogether an angle. So, theta plus 60 degrees is equal to the cos inverse of a half, or the arc cos of a half. Now, first of all, a half is positive. Cos is positive in the first and fourth. Therefore, if I pick my calculator like this, if I pick my calculator and I press the cosine of a half, what I'll get a 60 degrees. I'll get a 60 degrees. But how do I get the second one? How do I get the second angle? Cos is positive because you are in the first, all of them are positive. Then they are also positive in the fourth quadrant. So you get 360 and you take off the angle we've got, and this is none other than 300 degrees. So we have theta plus 60 is equal to this. So how would we get the theta? Theta will be got by getting 60 degrees minus 60 degrees and 300 minus 60 degrees. So we have 0 degrees and 240 degrees as the value of theta. Let's look at Roman 4. Roman 4, we have tan of theta is equal to negative 0.7660. I've included this one for a purpose. Actually, all of them that I've pressed here, I've pressed them there for a purpose. Now, when you look at this, it is negative and is given decimal points. Why I have included it there is to ensure that when you look at that decimal point, it doesn't give you something to overthink about and say, now there is some rocket science there. No, just do the same thing. Tan arc of negative 0.7660. You remember what I said in example 2? What I said in example 2, I said if you have a negative ratio in your calculator, treat it as a positive, but use the technique. Tan, if you look at this, tan is negative in the second and the fourth. Okay? Now, if you treat it as a positive on the calculator, what are you going to get? Let's see. Arc tan of 0.7660. You'll get, if the angle is to if the angle has got decimal points, your answer should be to at least 2. I prefer 2 decimal points. So we have got 37.45. 37.45. We've got 37.45. So if we've got 37.45, if we got 37.45, is it the one that we are supposed to write here? No. No. Reason, I've said you treat it as a positive. To get the reference angle, this one is our reference angle. Why am I calling it the reference angle? It is the one that we are going to use. Tan is This is negative, remember. Tan is only positive in the first and third. So if it is, we are given a negative ratio, we are supposed to consider the equations in the second and third to get what is required. And that is none other than 180 minus 37.45 and 360 minus 37.45. So if you get 180 minus 37.45, what do you get? You'll get 142.55. If you get 360 minus 37.45, this one will give you 322.55. Are you following? And indeed, if you press the tangent of this, you'll get a negative 0.7660. Okay? If we go to Roman 5, Roman 5 is a bit unique. It is tan theta is equal to 2 sine theta. Why is it unique? We have two ratios. Now, you express this in terms of sine theta over cos. I gave it to you. Tan theta is sine theta over cos theta. This one is equal to 2 sine theta. You cross multiply. If you cross multiply, you'll get 2 sine theta cos theta is equal to sine what? Theta. I've just cross multiplied there. Now, don't dare cancel out with the sine thetas because you can see I have a sine theta the other side and this side. No. You bring the sine theta this side, so you have 2 sine theta cos theta minus sine theta is equal to what? 0. The common factor is sine theta into 2 cos theta minus 1 is equal to what? 0. So, either sine theta is equal to 0 and theta will be the sine arc of 0. So if you press on your calculator, sine arc of 0, you are going to get as many as you cannot imagine. One of the angles you have 0. In other words, all the angles on the horizontal line, we have 0 degrees, we have 180 degrees, we have 360 degrees. All those angles will give you a 0 if you press them. Or here we have 2, it is cos. 2 cos theta minus 1 is equal to 0. In other words, cos theta is equal to a half. Or theta is the cos arc of what? A half. And indeed, the angles are still here. The angles are still there. So we have 60 degrees and 300 degrees. Now, for you to give something in it, you rewrite all of them, but in ascending order. That is, you start with 60, so there's 0, then 60, then 180, 300, and 360 degrees. So this is how we do that. That's how we do that. We are going to come across something similar to this sometime to come. Don't dare do things according to your own will. Do things as they are supposed to be. So I'm trying to take you through all these numbers. Now, there is this example. When I do this is Roman 6. I will not do Roman 9. Reason, I would have emphasized this idea of 2 theta. I would have emphasized the idea of 2 theta because it is something very important. The idea of 2 theta is very important. I want to emphasize it. So let me look at Roman 6. Let me look at Roman number 6. Now, When you look at Roman number 6, oh, it is Roman 6, not 4. It is here, cos 2 theta is equal to 0.6428. Now, of course, 2 theta is the cos arc of 0.6428. Something like this means that you are going to rotate 2 times. Move the first revolution. Now, focus here. 0.6428. That is a positive trig ratio. It is a positive value. So if it is a positive value and we are dealing with a cos is positive in the first and the last. Okay? So you'll come to your calculator and you press the cosine of the arc cos of 0.6428, which will give you, it will give you 50 degrees. So if it is giving you 50 degrees, how do you get the other angle? We have said cos is positive in the first and the last. Here, use the trig equation. The trig equation is 360 minus theta. In other words, it is 360 minus the 50 degrees, giving you 310 as 2 theta. Now, these values you're seeing here are corresponding to the angles in the first revolution after rotating once. So how are you going to get the other angles? The other angles are very easy to get. The next angle will be, based on the equation here, we have 360 plus the angle, the first angle, our reference angle, and that is 410. You move, you come back. Here we have 720. We have 720. It is 720 minus the 50, giving you 670. It is giving you 670. So if it is giving you 670, how do we get the theta? How do we get the theta? For us to get the theta, just divide all through by what? Just divide all through by 2. Just divide all through by 2. So if you divide all through by 2, 50 divided by 2, this one gives you 25. 310 divided by 2, this one is 105 degrees. 410 divided by 2, we have 410 divided by 2. This one is giving you 205 degrees. And we have 670 divided by 2. This one is giving you 335 degrees. Are you guys following up? So, the idea of 2 theta, there is that one person who would come here and from nowhere he divides through by 2. No, don't do that, please. The 2 is a compartment, is part of the theta. So, this is how you're supposed to do it. That's how you're supposed to do it. I want to look at Roman 7 for a purpose. Roman 7 is tan squared theta is equal to a third. It is equal to a third. Now, tan squared theta, note, tan squared theta is the same as tan theta, but everything is squared. Okay? In a trig form, we have to write it like this, but its meaning is that one. Therefore, I can say that I have the tan of theta, everything is squared, is equal to what? So how do I with that? How do I do away with this 2? You take the square root on both sides. So this one is going to be tan theta is equal to plus or minus 1 over root 3. So when tan theta is equal to 1 over root 3, theta is going to be the tan arc of 1 over root 3. Okay? Tan arc of 1 over root 3. We have 1 divided by have 1, we are dividing it by root 3. Then shift tan of the answer. We have 30 degrees. We found it somewhere. It is positive. Tan is positive in the first and third. In the third quadrant, the trig equation we can use, we have 180 plus the angle here. So 180 plus 30, you get 210. That one is done. Then we have when tan theta is equal to negative 1 over root 3. So for negative 1 over root 3, we have, for negative 1 over root 3, we have theta is equal to the tan arc of 1 over root 3, and that is none. It is negative. You have to write it to show it is negative. But I've said you treat it as what? A positive. You treat it as a positive in feeding and the calculator. When you treat it as a positive, you'll get a 30. Now if you get a 30, tan is positive in the, tan is positive in the, no, we are having a negative. Tan is negative in the second and fourth. Second and what? And fourth. So, after getting the 30, I'll get 180 minus 30, giving me 150. And then 360 minus 30, giving me 330 degrees. Then, therefore, my value of theta for this, you could look at it as something very tiny, and someone may take it as a normal thing. You rewrite it in ascending order. You have 30, you have 150, you have 210, and 330. All those are in degrees. Ladies and gentlemen, I guess we are together there. I want to look at one more. Of course, Roman 2. So Roman 8 is just need to simplify, so to factorize. There's a common factor tan. Then how about Roman 9? Roman 9, 2 theta is the key issue, but it is not that ambiguous. Let me look at the last one, because that one, I've chosen it for a purpose. I'm just going to direct you on something, and then you can complete it. It is 2, this is Roman 10, 2 cos squared theta plus 3 cos theta plus 1 is equal to 0. I've just said when you find something like this, just know it is something like cos of theta but everything squared. So with that said, you can easily see that that is a quadratic equation, but in a trig form, meaning if it is a quadratic equation in trig form, the way to go is very simple. Just consider it as a quadratic equation and solve it. So you have cos squared theta plus 2 cos theta, those are factors, plus cos theta plus 1 is equal to what? To 0. Plus 1 is equal to 0. So you have 2 cos theta into cos theta plus 1 plus, in the brackets, cos theta plus 1 is equal to 0. We have cos theta plus 1 into 2 cos theta plus 1 is equal to 0. So either cos theta is equal to negative 1 or 2 cos theta is equal to negative 1. We shall continue from there.